All right, so we already talked somewhat about the internal structure. So we've seen that Uranus and Neptune have this ionic ammonia slush region below the molecular hydrogen layer, where we think the magnetic field is actually generated. And again, the strong magnetic fields are powered by fast rotation. All of these planets are rotating quite a bit faster than the Earth. So they have that rapid rotation. They have the electric conducting layers. Those are the ingredients that are required for magnetic fields. Now, one unusual thing about magnetic fields of Uranus and Neptune is that they're not actually centered on the core of the planet. They're offset, which we think has to do, again, with the fact that there's an ionic slush layer that's actually creating this. It may not be a uniform layer. There may be more currents in part of this than others. In other regions, may be more frozen and less able to actually conduct currents. So the bar magnets that are stuck in there are basically what we call the equivalent bar magnets that kind of would create the same field. Now, strangely, we also see that the magnetic field is very strongly tilted with respect to the rotation axis, 46 degrees or even 60 degrees in the case of Uranus, whereas it's only a few degrees in the case of Earth. So we don't really understand that very well at this point. Now, here we're seeing Jupiter and Saturn thrown into the mix. They're equivalent bar magnets. They're more central, so somehow the metallic hydrogen layer or some electrical conducting fluid is more symmetrically distributed around in hydrogen in Jupiter and Saturn, and it's again more offset when we look at Uranus and Neptune. Probably simply because it's a different physical mechanism that creates the currents. All right, so we've seen that Saturn has this very significant ring structure, and in fact, you're still on? Are we live? Yes, we're live. But we do see ring structures even around the other outer planets, but the dominant one is of course the ring structure around Saturn. The Saturnian ring structure may only last for hundreds of thousands or millions of years because it's a very dynamic system. All the particles in the rings of Saturn are actually gradually falling down towards Saturn, and they'll gradually burn up in Saturn's atmosphere. They must be replenished by new small moons that wander into that Roche lobe area, that Roche limit, where they get ripped apart. And then what happens is they're actually able to replenish the rings with fresh little snowballs, right? Well, eventually that might stop happening with Saturn, but it might happen with one of the other outer planets, and so it could turn out that Neptune would be the dominant planet with rings in the future. It's also worth pointing out that, if you look at this, we have the Roche limit, which is that red line up there. Now, remember that we looked at the F ring of Saturn, and I even showed you a video of these little so-called shepherd satellites that were cruising along right near that thin F ring at the top of the diagram. There was one just inside the F ring and one just outside the F ring. But I've been saying that when you move inside the Roche limit, your satellite's supposed to blow up, right? I mean, if the satellite gets ripped apart because the stretching force due to the tidal effect of Saturn overwhelms the self-gravity. And that's when your moon disintegrates and it turns into a source of ring particles. So how can we have shepherd satellites right near the F ring, which is inside the Roche limit? That seems like a paradox. It seems contradictory, right? But the reason is because we're talking about bodies now that are so small, they're actually not held together by self-gravity, but instead they're held together by molecular forces. So let me give you another example. Suppose you took your washing machine, and suppose your washing machine is old and outdated, and so you don't want it anymore. But instead of taking it to the recycle landfill, you fly it out to Saturn, and you drop it in. Well, as your washing machine passes by the Roche limit, what do you think is going to happen to your washing machine? You think it's going to blow up, right? That doesn't happen because, you see, washing machines are actually held together by molecular forces between the metal molecules and atoms, right? So a washing machine is not held together by self-gravity, held together by molecular forces, which are electrical forces that are much stronger than gravitational forces. So if you drop your washing machine into Saturn, it will just pass right through that Roche limit and it won't blow up. So we think that the small shepherd moons around the F ring are small enough bodies that they're actually icy objects that are held together by their own self-gravity, and therefore they don't get ripped apart because the electrical type of force I'm talking about is much stronger than the tidal force. So that's the basic reason that we're seeing the Shepherd satellites. I hadn't covered that before, but I wanted to mention that because I think it's on the exam. An interesting technique was used to discover the ring system of Uranus because what we're seeing is an occultation which occurred when the planet and its rings moved in front of a distant star. And what we actually saw was the starlight at early time was completely unaffected, but then we see this funny choppy dropping off of the intensity of the starlight, which basically indicates there's something in between, including particle light. So this is actually the evidence for the three rings of that, and then a lot more structure was seen during Voyager operations. And okay, so I need to move through here. Okay, Neptune has another braided ring, probably all very similar to the Astr ring, probably due to Shepherd satellites. Again, you see Shepherd satellites there. Okay, let me just go back to my diagram for a second here. Yeah, let me see that there. Okay, so forward. Now we still have to talk a little bit more about okay, moons of Uranus. Okay, we're talking about very icy bodies, even less than 2 grams per cubic centimeter. So very similar to the moons of Saturn. These are almost pure ice, not much rock at those low densities. And Miranda is a particularly unusual one that looks like it's been suffered an incredibly violent collision because it looks like chunks of it have flown apart and then been reassembled gravitationally. So you can do completely bizarre juxtapositions of different types of terrain. So clearly a very violent path for that particular moon of Uranus there. Moons of Neptune, we had talked about before. Triton and Nereid, again, icy bodies. Notice Nereid has a density of 2 grams per cubic centimeter, pretty much exactly the density of Pluto. So again, this kind of supports the idea that we may be seeing that Pluto could possibly be, as I say at the bottom there, an escaped moon of Neptune. Okay, that's actually Triton. Triton is one of the icy moons of Neptune, orbits in a retrograde direction, probably indicating it's a captured satellite. All kinds of chaotic things happen in the outer solar system. This is an icy body without an atmosphere, so it's nothing like Titan around Saturn. And shot of Triton with Neptune. Icy surface, probably fluid and lake-type things on the surface there. Radiation darkening on parts of Triton. An artist's conception of Neptune rise from Triton. And let's talk a little bit more about Pluto and Charon. Okay, so again, Pluto was discovered to have its own satellite in 1978 based on this kind of crummy photo here that was taken at the Naval Observatory. Upon its discovery in 1978 was the first time we realized that it was really a double orbiting object with a moon that's 1/6 of its own mass. And lately, we've started to realize that Pluto probably isn't really a planet. It's probably just another example of what we call a Kuiper belt object, which are basically cometary nuclei of various sizes that are very primordial in nature, and for the most part orbit around the distance of Neptune in what we call the Kuiper belt. So Pluto may have maybe an escaped object from the Kuiper belt, or it could be, again, an escaped moon of Neptune. Now, this particular diagram here makes it look like Pluto is the dominant object, but since that time, we've discovered a few other Kuiper belt objects that are actually larger than Pluto. Like in 2003, we discovered Eris up in the upper left. A little bit larger than Pluto. So that's pretty much kind of the breaking point. We had to make a decision. Okay, we're going to call Eris another planet, or are we going to basically say that Pluto's in another category of its own, which is what we call a Kuiper belt object again. Okay, so Pluto and Charon, the original discovery photo of 1978, really crappy because we didn't have the angular resolution to resolve the actual gap between Pluto and Charon. This particular ground-based photo, you can cleanly see that they're separated objects. And then if we go forward to Hubble, this is a really nice photo because we're actually seeing the surface of these two objects now, and they're clearly pretty comparable in size. And actually, it turns out we originally discovered that Pluto has some additional small moons, which, again, is something we probably need to explain using collisions or interactions of some kind. We don't have any direct images of Pluto's surface, but First Mason is participating in a mission called New Horizons, which is on the way to Pluto at this very moment, and will arrive there in 2017, I think, and give us our first actual view of the surface of Pluto. These are computer-enhanced images that are based on variations in the brightness of Pluto as it spins. So we kind of deduce it looks like this. Probably a radiation-darkened surface. We're probably going to find it looks a lot like one of the moons of Neptune, again with that radiation-darkened surface. But we don't really have photos yet. This is a comparison of Pluto and Charon with that horizon map that you see on TV now, right? So there's kind of like the United States there. Horizon works underwater. You can see that in the upper part. So here's Pluto and Charon compared to the United States. This actually was caught during a trip to Stony Hills. We were going shopping. I have seen that. It was massive congestion on the belly the other day. Okay. We might ask how we even know what the densities of Pluto and Charon are. The mere fact that we discovered them in 1978 doesn't mean that we know how massive they are or what the densities are. We just sort of know how large they are, but not their masses. But the fact that Pluto and Charon are orbiting around each other gives us a way to compute the mass because there's a gravitational force that's required to create the orbit that we see. And there's another interesting thing that happens, which is that they can actually occult each other or move in front of and behind each other as viewed from Earth because of the tilt of their orbit. So in 1988, they actually moved in front of each other, and the way in which their light was blocked gave us a way to measure the actual sizes of the bodies themselves, not just their orbital distance, but with the amount of time that Pluto's light was blocked by Charon, you could actually use that to compute the size of each of those two bodies. And that's the reason that we were actually able to know their sizes and hence get their densities. So this is something that only occurs every 124 years, so it was just a lucky thing that happened in the mid-1980s and gave us the ability to know what their sizes are, which meant that in the 1980s, it was the first time we actually could compute the densities of these two bodies and know for the first time that they're actually icy compositions. We couldn't know that if we didn't know their sizes and their masses. This is just another figure that shows the scale of the type of orbit. And again, this is the New Horizons mission. I don't think it's getting there in 2014. I think it got pushed back to 2017 or something like that. But Mason is actually participating in that. In fact, that the chair of our department, our astronomy department here, is one of the main scientists on that mission. Okay, so just to finish out this chapter, and then we'll do the review of the multiple choice example test. There's things we don't understand about the outer solar system. We don't understand, for example, why Saturn has this amazing ring system, but none of the other planets do. We wonder whether life could exist on that moon with an atmosphere, Titan. Uranus has this weird tilt, which we think is due to a collision, but we don't know for sure. We also wonder when were the moons of Uranus formed, because they're in the equatorial plane of the planet, but the planet's tilted. So does that mean the moons were formed first, and then the planet tilted, and then the moons kind of migrated back into the new equatorial plane? Or does it mean that it got hit before the moons formed? Yeah, it's kind of an interesting question. We saw that the surface of Miranda has very complex terrain, probably due to collisions again. And we also wondered, how could Pluto have its own moon system when it's supposed to be an escaping moon? That's a very complicated process. If you're going to get Pluto out of the gravitational clutches of Neptune and get it farther out, then how does it actually end up with satellites of its own? Especially with the very weak gravitational field that Pluto has. So that's sort of where we're at in terms of the mysteries of the outer solar system. Okay, so let me go back now and restart this and get back to the website so that we can look at